and my team name is Code Blooded. And the problem statement that we aim to solve is maximizing section throughput using AI-powered precise train traffic control. So I will be demonstrating the prototype that we have built so far. So let's begin. Firstly, we have this login page where you can have your employee ID and password. You can access your sector. So currently it is dummy sectors, it is not real sectors. So we will just do a demo login as the station master alpha. So as you can see, this is the home dashboard. So firstly, I will change the theme. It's too bright. So here we have the home dashboard. As you can see, we have a map. The map has a centralized station CST and branches off into multiple stations from it. As you can see on the right, we have the labeling of the map. We have signals, we have train tracks, and the types of the trains. So currently there are three trains that are traveling, as you can see. So if we filter by trains only, we can see that we have these three trains that are moving throughout the tracks. Next up, we can see the signal. So only one signal is currently red, and that is this one. Also, there are two occupied sections, which are these two. One of the trains is only running on time. And lastly, we have the track. This is the track that the trains are running currently. Once again, this is dummy data and it is not real data. Next up, let's move to live tracking. In live tracking, you can basically see which train at what particular state it is. So as you can see, firstly we have this Rajdhani train. It is going from Dadar to Mumbai Central. Next we have Agast Kranti. Next we have Deccan Queen, and each also shows the type of train, whether it is passenger, it is freight train, or whether it is local. Further up we have the signal, as what signal currently the train follows. Here we have green, here and here red. Also we can see the details of the trains, from where it started, where it is currently, is it stopped, or how much time it will take. We can filter throughout the sections. If I show passenger, only passenger will be shown. Then if I show delayed trains, so these two trains have been delayed. And then once again, if I choose a station, for example, let's go for Grand Road, we can see that this particular train is currently at a red signal and it is going from Grand Road to Churchgate. Lastly, we can further dynamically view our list. We can have a grid view, and we have the smallest, that is a compact view. Next up, we have the decision support. Here the AI tries to give you support decisions. In case you are not 100% confirmed, you can view the AI and it will further help you. The AI is most important in figuring out the loose time between the train traveling. The higher priority trains will often get a less loose time and they will reach their destination quickly. And the trains that don't have higher priority, which have low priority, will have a lot of loose time, and therefore they will take a lot of time to reach their destination. So again, it depends on the priority. Once again, this is dummy data. This nothing is subject to change. Here the AI recommends the actions that you can perform. For example, if one of the trains, if you look at here Mumbai Ahmedabad, if we reduce the speed of this train, further we can, instead of stopping it at a particular station, just by reducing the speed and putting it on another loose track, the higher priority train can go, and which can further reduce the overall loose time. We also have this Karjat station. It is saying us to hold the train for 7 minutes for another train to come. Next up, we can also apply these, or we can simulate it first, or we can override the AI. Next up, we have the train management page. Here you can see the details of what is currently happening with the trains. So as you can see, we have central and western line currently. We have a lot of trains that are traveling. As you can see, we have this second train Mumbai Central to New Delhi, and currently it is between Valsad and Surat. And estimated time of arrival is basically 3:10, and the capacity is almost full. The train is 96% full, and it's an express train. Now we can change the priority to whatever we want, and then that affects the loose time of any other. Once again, we can filter throughout, and we have our filters up there, or we can directly search. Next up, we have the optimized path. Here, the AI tells you what is the optimized part or what it should be. since most of the tracking is already done automatically. In case you need to make a particular decision or you want to change, the decision support and optimized path helps you in guaranteeing it and making it more efficient. For example, we have these active routes. We have this train going from CST to Mumbai Airport link. How do I calculate the least amount of time? How do I achieve more efficiency? So this can be done via our AI models. So firstly, we will have a look on the different types of trains that are currently. We have a lot of trains. As you can see, some have 96%, some have 91% score, 88% score. We can use our network view. So the network view is basically a way of saying how many trains are occupied at a particular station. As you can see on CST, 18 trains can be occupied at a time, and currently 15 are only occupied. Further, we have Dadar, Thane, and etc. Next up, we have the analytics page. The analytics page mostly helps in determining overall graph systems for our thing. For example, what is the metrics of our performance over time? How much time is saved over a long period? So currently we do not have this long-term data, so that's why our graphs are not rendered. Next up, we have algorithms. So we can also assign algorithms for our optimized path. For example, we have the classic Dijkstra's algorithm, we have genetic algorithm, we have reinforced learning, which is currently active as you can see, and then we have the A star search, which is based on heuristic based path finding. Next up, we have accident and warnings. Basically, what sort of accidents can happen and what will be its outcome. So as we can see, a lot, one of the is critical state currently, and we will address it firstly. The collision risk. Two trains detected on the same track segment between Kalyan and Thane. Basically, there is a collision risk which can lead to a lot of deaths, and this should never ever happen. And we need to be careful and move accordingly. Next up, we have some trees fallen on the tracks due to a storm. We need to get rid of those trees. A power failure happened in one of these places in Howrah station. There is weather warning, there are visibility issues. We can acknowledge this or we can once again escalate and move on. Then we have the risk map. Again, this shows alerts across a network. So this is basically over a high area. Lastly, we have the analytics. The analytics basically requires time data and a lot of data at once to actually execute. Next up, we have the prediction analytics. Basically, if you try to predict what are the chances that it will happen, so we can have different versions of risk currently affecting your trains. So what can it be? We have a collision risk which should never happen. We have weather impact and equipment failure. So the equipment failure chance of happening is 80% within the next week. How likely is this and how can we prevent it? So firstly, we have to find out the location, find out the maintenance crew and send them for assessing the problem. We can ask our AI models, for example, the monsoon. We can track the monsoon of a particular city or an area for a few years, and then we can say what will be the weather tomorrow or day after tomorrow or in a month, just like our weather forecast predicts. Then the factors currently that can affect. So for example, a lot of factors we have here including temperature, humidity, wind speed, visibility, track temperature and passenger load. So the greatest impact comes from wind speed. How much wind can affect the speed, and the next up is passenger load, 25%. Next up, we have the analysis, overall analysis. So basically, this chart requires a long time data, and once again, we do not have that much data, and we will be continuing on to the analysis performance. So here, as you can see, this is the data that we have been able to collect so far. So as you can see, a lot of trains, when the performance trend shows that a lot of trains, when they start, the average delay fluctuates between 25 to 4. That is the average. And only 85% of them are on time. Next up, we have the section utilization. What sections are most commonly utilized? As you can see, the most commonly utilized section is 92%, which is B2 to C3, aka in real words, which would be CST station or Mumbai Central. Next up, we have the train type distribution. Which type of trains are currently moving across the tracks more frequently? As you can see, the greatest share is with the passenger trains of 45%. Next up, we have the hourly throughput. What time most of the trains are traveling? So here, as you can see, at 4 p.m. in the afternoon, a lot of trains are traveling through the tracks, and this can be for a particular station. As you can see here, the dummy data shows us 32 throughput. Further, we have the past records. The past records basically show us a historical archive of records that we have collected so far. So currently, we have these stations. We have Thane, Neral, Borivali, Mithi River, Andheri, Borivali, etc. So we have a lot of records, as you can see. We have 50 records in fact currently, and we can scroll through them. We can once again filter through them. Then we have the trends, yearly trends. What trends happen on a yearly basis? As you can see, in 2020 we had 11 incidents, and in 2023 we had 12 incidents. So we should aim to minimize these incidents as less as possible. And lastly, we have analysis for this page. What is our resolution rate? How much time does a particular incident gives the response time for it? And it is average, it is 2.3. Some can take a lot of time, some can be resolved quickly. And what is the average cost per accident? Currently, it is at $50,000, and preventable incidents is only 23%. So a lot of incidents still happen, and we need to be afraid of it and prevent such scenario. And further, we have one of our most important section, that is the simulation. So the simulation basically tries to create a new scenario and simulate it. So for example, if I create a new simulation, let me say as a signal issue at Dadar. We can describe the issue as a signal power failure at 10 p.m. The delay type will obviously be maintenance. The duration, let's keep it as default as 5. The affected train, we can leave it as empty, then it will affect all trains. The location we would likely to add is actually going to be Dadar itself, as the train cannot pass through it. And let's let us create the scenario. So here we have the signal issue at Dadar. So if we run the simulation, it is currently running the simulation, and it shows, the AI shows that a total delay of 19 minutes can happen with the affected percent of 3 trains. So 3 trains can be affected by a single signal power issue, and this can have a butterfly effect throughout. Further, we have some built-in simulation that we can run. For example, we have this platform congestion at CSMT. If we run this simulation, as you can see, it is running, and 35-minute delay was caused by this platform congestion. Once again, CST is a big station. It is one of the most important station, and therefore platform congestion is very likely to happen. A 35-minute, almost more than half an hour, and 5 trains were affected. Next up, we have the advanced simulation. So here you can basically track and keep everything that you want to simulate. You can start, pause, everything you can. For example, let us start with one of our built-in. We can have a Mumbai suburban morning rush. For example, if you run it, as you can see on the left side, the simulation is currently taking place. We can once again change its speed. We can once again change the intensity of the traffic however we like. Let me just make it 10 times 10x so it executes as quickly as possible. And now the simulation has executed completely. So here is the performance metrics and the network overload from the simulation, as you can see. The peak was at 1 minute. The performance metrics also, it initially started as really slow, but went really high. As you know, Mumbai suburban morning rush is actually very different and very difficult. Then we have the stress control. Basically, we can have different types of stress simulations. You can have response time, peak hour, cascade, and maximum throughput. We just did a peak rush hour, and let's do a maximum throughput test. So here, push the system to maximum train handling capacity. So basically, you can choose a scenario, you can create a scenario, and you can see what happens to it. As you can see, it is being in progress. We also have the real time monitoring of it. Further, we have the result analysis of what is the current throughput, etc. The system stability is 88%, which is still good, but it should be as near to 100% as it can be. And that is the advanced simulation. Lastly, we have the settings page. So the settings page currently is being worked on. We are planning on adding our custom APIs for students and other users to manage railway data. Once again, we have dummy data, and if we can extend and elaborate our dummy data, then we can provide a custom external API. We also are working on user management currently. As you can see, I was logged in as the station master alpha. Next up, we have the audit trail. Audit trail is basically an compliance of all the actions logged. So as you can see, 2,800 decisions were logged in. That's the 98% is the compliance, a very good compliance rate. And we have 156 active users currently. Once again, this is dummy data. It is subject to change. And thank you for viewing this video. Dear viewers,